Hi, my name is Mr. Lloyd Davis and I teach science physics at GCSE and A-level at Tonnereville Community School. I've been teaching here for the last 3 or 4 years, and I believe that our physics department has gone from strength to strength and our grades are improving all the time. So why is physics relevant today? So recent advantages in physics often enable new advances in technologies. And a great example of this, advances the understanding of electromagnetism, right? It's something you cover at GCSE and at A-level. Solid state physics, nuclear physics led directly to the development of a new product that have dramatically transformed modern day society, such as television, computers, and domestic appliances. Advances in thermodynamics have led to the development of industrialization and advances in mechanics. It is continuous and ongoing development in physics. Recently, we've had the James Webb Telescope sent into space, and that is going to completely change how we see space over the next couple of years. All right, so careers that require physics. Mechanical, civil engineers, all right, all different types of engineers, data analysts, operational researcher, patent attorney, architect, telecommunications engineer. There's so many different areas, We've got anything from Formula One engineer through to in sports now, they are sports scientists who look at angles and look at forces and look at everything to get to maximize every aspect of sport in order to get a cutting edge and any sort of advantage over their opposition. So you've got so many different types here. If you have a look, that is not the end of the list. It goes on. They're just a very small selection of potential careers you could have should you choose physics. A couple more. So astronomer, clinical scientist, lecturers, nanotechnologist. Right? A lot of these are getting massive funding at the moment because we're understanding the importance of physics in terms of research development, and then it leads us on to greater technological advances. All right, so the course itself. The course itself is a 2-year course. Right, year 12, the first year, is the AS level. During that year, we will cover Unit 1 and Unit 2. So Unit 1, we cover motion, energy, and matter. That is looking at same things we looked at in year 11 and 10 in a little bit more detail. And same with Unit 2, electricity and light. We cover a lot of that at GCSE, but we go into more detail in A-level. The bit you should know about this is it includes a lot more maths, right? So if you're taking maths at A-level, it's a great help for when we're covering A-level physics. So you've got 2 units there, 2 exams, 80 marks each, right? Each exam is at 1 hour, 30 minutes. A mix of short answers, some maths, and some longer 6-mark questions. Year 2 is a little bit more in depth. So you've got 40% of the course is year 1, 40% of your overall marks, 60% of your overall marks is year 2. Unit 3 then is oscillations and nuclei. Again, the exam is now out of 100 marks, 25% of your overall qualification. All right, just broke down in 2 sections, 80 marks, typical exam style questions, and then 20 marks on a comprehension question. Unit 4 then is fields and options. Again, 80 marks of that is in an exam. And then we've got an optional for 20 marks. And that optional, you can choose anything from alternating currents, medical physics, physics of sport, or the energy in the environment. And we can choose one of those topics when we get to Unit 4 in order to complete our A-level. We've got Unit 5, which normally happens early in the year, in the second year of A-level. And this is 10% of your overall qualification, where we will complete a practical exam with 50 marks. So we'll do a practical experiment, and then we'll write up the experiment afterwards. Okay, so what are we looking at year 12 in a little bit more detail? What do we learn? The first part is basic physics, where we look at vectors and scalar quantities. We look at the units. We look at what makes up everything in order to you can clearly identify where these formulas and everything are coming from. Then we got kinematics and dynamics, energy concept, solids unstressed, using radiation to investigate stars, and particles and nuclear structure. Unit 2, conduction of electricity, resistance, DC circuits, nature of waves, wave properties. All right, everything you've built in, both of these units are things you're building on, right, from year 10 and 11. It's the same topics, but we're going into a little bit more detail and applying a bit more math theory to the work. All right, so about me a little bit more then. So as a teacher, I'm not one to stand in the front of the class and just dictate, copy down at A level or any level actually. But for this one, I really prefer self-learning in the classroom through increased peer to teacher learning. And what I mean by that is, I will give you an chance to answer it yourself first, have a go. Then we talk in groups, then we talk in bigger groups, then we discuss the class, then you'll share your answers. And at the end, if we can't come over to sort of an agreement, I will then help step in and give you a more thorough answer and help you in terms of understanding the topic. But everything is sort of developed slowly, incremental steps in order to help maximize your learning. I use activities to promote self-discovery and develop problem-solving skills. Okay. Again, I don't just give out answers. We'll have to work it out ourselves. Right? Problem solve, making you a far more robust, self-reliant learner that allows you then to move forward in your industry. It'll help you when you go to jobs, when you become more self-reliant, you're fixing your own problems. And I believe those sort of skills start in the classroom. We start off very small. We don't just give you, fix them. We start off very small and we build. And by the end of the year 11, year 13, you should be far more self-reliant and able to come confident in explaining your answers in a mature, scientific way that allows you not just to get good grades at A level, but become a confident, self-reliant person that can verbally and produce verbally written competent questions that allow great job skills in the future. This all leads, to you developing a much deeper understanding on this topic. This has proven in the last couple of years where our grades are just getting better and better. Okay, so as we look in there, we've got a little diagram to show I firmly believe in you guys helping and teaching each other as well as me helping and teaching you. Okay? It's not unusual. In most lessons, if you've got an answer, that's good. I will ask you to put it on the board for everybody else to learn from. All right, to study A-level physics, what do you need? Now, there's normally a lot of criteria when you go into A-levels on who can and who can't sit. My belief is physics is for everyone, okay? We don't stipulate entry requirements for A-level physics. They do in a lot of places. However, you do need to understand that physics is a very demanding subject. You need to be prepared to work hard, not just in the classroom. You've got to put the hours in outside of class. Okay? I can't stress that enough. If you're just relying on the classroom work, okay, it's gonna find it difficult long term. We need to be putting in the effort in class and outside of class. Should you apply, you will be invited for a one-off interview, right, from the senior school staff. This is where you'll discuss your suitability for the course and see if it's an appropriate pathway for you to follow. Because physics is science, you already have a GCSE in science, so the knowledge and understanding, you should have the basics there and be able to interpret the data for the graphs, tables, calculation, statistics. Again, I would like to reiterate that at A-level physics, we prove a lot more theory using mathematics. Okay? It's very maths-based A-level physics. Thank you again for visiting Tonga page today. I hope you all apply for physics. I take great pride in my physics A-level class. Nothing better than watching a person develop as a physics student, but also I take great pride in if they can develop as a person. I do as many different activities as I can in order to prepare you for university, things from video blogs, presenting to the class or just to me, depending on your conference levels. Right, it's all about developing your all-round skills, not just your physics skills. I look forward to seeing you and cheering from you in the future. If you have any questions, please contact the school or myself. I'm more than happy to meet with you or discuss with you to discuss any further issues. Thank you very much. Diolch.